Well, today I am going to be going over how you can write a proof to find out whether a map is linear or not. The two things we want to check for is whether or not it likes addition and likes scalar multiplication or is closed under. I'm going to be having alpha represent addition and beta represent our multiplication. So first, this is the first map we got to check. Sorry, you can see I started already. So let's check axiom alpha. We first have to define our terms. And say that they are in R2. It's very important that you pay attention to what your inputs are and what your outputs are, because if you mess that up, the whole proof is going to be useless, basically. So just make sure that if there is like a Z there, to include a Z there, so on and so forth. Now, let's check S applied at V1 plus V2. What this is going to have us do is it is just going to have us put our X1, X2, our Y1s and Y2s right next to each other. So for the first one, it is X1 plus X2 plus 2 in parentheses Y1 plus Y2 minus 4. Now, if we wanted to multiply this out, we have X1 plus X2 plus 2Y1 plus 2Y2 minus 4. At any point in the video, if you feel like you have a hang of it, feel free to pause, stop, and see if our answers match up at all. Now that we've gotten that, we are going to see if it matches S at V1 plus S at V2. And basically, instead of putting that X1 and X2, Y1, Y2s next to each other, we are going to separately put the X1s and Y1s and then add them up at the end. So if you're confused what I mean by that, I will show you in a second. So if you can see here, I put the Y1s and Y2s next to each other, and here I am checking them separately. Now let's add these all up to see if they're the same. We have X1 plus X2 plus 2Y1 plus 2Y2 minus 4, which we know these are minus 8. And since we have a minus 4 here and a minus 8 here, we know these aren't the same. Therefore, alpha fails. And since alpha fails, we can conclude that S is not a linear map. Did you pause and check? Did you get the same answer? I hope so. Let's go ahead and check another example. Let's call this problem B. And we see in this problem, this is exactly what I was talking about by making sure you check your inputs and outputs. For this one, we see we got 3 there. Okay, so first we want to check alpha. And we know from our previous example that what we're going to want to do is define our terms. I'm just putting my x1, y1, z1, and my v2 being x2, y2, z2. Make sure that these are all in R3. Now let's do exactly what we did with the last problem and check our t v1 plus v2. So we remember from last time, this means we just have to put those variables next to each other, basically. Z1 plus Z2. Now, multiplying this out, it's pretty explanatory. We just have to put that 3y1 and 3y2. Okay, now that we did the first part, let's do it the second way to see if they match up. Now, again, this one is just doing them separately and seeing if our answers match up. Okay, x2 plus 3y2, z2. Now, just by looking at it through inspection, we can tell we have an x1, we have an x2, we have a 3y, we have another 3y, and we have our z1 and z2. You can rewrite those in that exact same form, but just to save time, I won't. And this shows us that alpha passes. It is closed under addition. Now let's check our axiom beta. Now with beta, which we haven't gotten to because our first one wasn't a linear map, we are gonna start by doing the same defining. In this one, we just need to use 1. So let's have v equal x, y, z. But we also want to say A is in R because A is going to represent our scalar multiplication. Okay, so now that we did that, the 2 ones that you have to check for scalar multiplication to see if they add up is A multiplied by, in this case, we have T. So T at V, and then T multiplied A and V. Maybe it sounds complicated. Once we write it on paper, I'm sure you'll understand it. So we're first going to check TAV, which basically just means that we are going to multiply A by the whole thing. So A multiplied by X plus 3Y comma Z. This multiplied out gets us AX plus 3AY and then AZ. Now, I told you if it was confusing, it would make more sense when I wrote it out. Oh, I'm sorry, this was A multiplied by, that makes more sense now, doesn't it? And now we are going to do T multiplied A of V. So this one, we are just having A multiplied there. On this next one, we are just putting A next to each point here. And by inspection, those match up. So that means that our beta passes and it is closed under scalar multiplication. I got cut off there, so I'm just gonna write mult. Finally, alpha plus beta implies that, or we could say, means that T is a linear map. Thank you guys all for doing math with me. If you have any questions, please throw them in the comments below. We just went through an example of one that wasn't a linear map and the other which was a linear map. If there is anything that you want to see next, again, leave some comments and I will look into it. I hope this made things easier to understand. And thank you for mathing with me. All right, bye now.